low-key shocked at how much they incorporated into this without a whole lot of context. Of course, we did skip 5 chapters. However, the assumption is that you're super familiar with multiplying binomials and working through the quadratic equation. We haven't done that a lot in geometry because it's geometry. But like I said, that is a thing for algebra, and it's been a minute since I think y'all have worked with binomials and with the quadratic formula. So let's just, let me outline the main topics that are going to be involved. They make it look so simple on this page, and I'm like, there's a way more going on than just this. So, again, page 342, example 1. Okay, the things that we're going to be talking about, I'm just going to write them over here. Obviously, the Pythagorean theorem. There's a little more noise because my little one woke up. There's also going to be something called FOIL, which is an acronym. And it's a technique used to multiply binomials. Okay. And then the last thing, the main thing, there's a bunch of other subtle things involved, but the last main thing is going to be the quadratic equation. Excuse me. All right. So let's keep those things in mind and then sort of set them aside for now. Let's see if I can get this to work. Just sort of, what? Never mind. All right, cool. So let's look at what the book gives us. We're given a right triangle, okay? And we know one of the legs is x, and we know the other leg is x plus 7. And then the hypotenuse is c, okay? So given the Pythagorean theorem, which states a squared plus b squared equals c squared, we can plug in these values, excuse me, for a, I'm going to call this one a, b, and c, right? So a is x. I'm going to plug that in for a, and I'm going to call that x squared. B is x plus 7. All of that is b. So that's going to get grouped together, and then I need to square it per the Pythagorean theorem. And then c is 17, and then I need to square it because that's in my formula. Okay? Now, this is where FOIL comes into play. Okay? FOIL is how we multiply binomials. And this right here, when we write it out, remember like when we have like 5 squared, that really means 5 times 5. Or when we have 3 squared, that means 3 times 3. Well, when we have a binomial like x plus 7 squared, that's going to be x plus 7 times x plus 7. Okay? So we're just going to write this out again in standard form, x plus 7. I'm sorry, not standard, but factor form. Okay? And then we've got the 17 squared that we'll deal with later. Okay? FOIL is the technique for multiplying binomials. FOIL stands for first, outside, inside, last. First, oops, I did a double, I doubled up on my O's. Okay, outside, that's a D, inside, last. Okay. So what first, what outside, what inside last? So these x's are the first that I multiplied together. Okay, so let me just, I'm going to bring x squared down again, plus, and then x times x, that's my first grouping, that's going to be x squared. So outside is the next thing that we're going to look at, okay? That means this and this. Do you see how these are both on the outsides of the binomial group right here? So then when we multiply x and 7, positive 7, we get positive 7x. Okay, so we've done first, we've done outside. Okay, let's look at the inside ones. Okay, y'all picking up on what we're doing now? So this inside one is going to be 7 and x together, and it's positive, so it's just going to be plus 7x. And then, as you could probably guess for last, we're going to do, these are the last ones, 7 and 7, and they're both positive, so 7 times 7 is 49. Okay, and then the rest of it stays the same. So this is FOIL. This is our technique for multiplying binomials. We do our first, our outside, our inside, and then our lasts. Okay, so now I think I can erase this and make some space for us because we're going to need lots of space. Okay. We're trying to clean up clutter. I'm going to go ahead and combine my x squareds. You can combine variables that have the same exponents. These two have the same exponents, okay? So let's go ahead and do that. X squared plus x squared is 2x squared. 7x plus 7x is positive 14x. No change with a constant. And let's go ahead and do 17 squared. Oh, thank you. Hang on. Sorry, Silas is bringing me money. Thank you. Which y'all could take out your calculators at this point if you need a quick way to do stuff, because this is not my concern right now. I'm not concerned about whether you're using calculators or not. I'm concerned with, do we understand the process? Okay, so 17 times 17, or 17 squared, is 289. If you're following along in the book, it has these answers, but I don't see a whole lot of explanation here for what we just did, because we have so far applied Pythagorean theorem, right? Which is right here, and we have applied FOIL right here, okay, and then we've applied combining like terms, which is right here. And if you want to talk about exponents, we've done that here too, okay? Now, here's the deal. This is where the quadratic formula, the quadratic equation, comes into play. Thanks, honey.
You have to say thank you.
Thank you. Okay, I'm teaching, right? All right, thank you. All right, so the quadratic equation says ax squared plus bx plus c equals 0, okay? This is the quadratic equation. Notice we've got a, b, c. Notice we've got x squared, x, and then nothing, no variable. So we're descending in our exponents, x squared, x, no variable, and then we've just got variables a, b, and c along the way, and it's always set to 0. This is the quadratic equation. And what they want you to do is they want you to get this, what we just solved for, in quadratic equation form. Quadratic equation form, remember, is set to 0. So what do we need to do to get this 0? We need to subtract 289, right? So I'm going to go ahead and just mark it here, minus 289 and minus 289, okay? That would equal 0 here. And then if you were to start from the beginning of this equation on the left side, you're going to go ahead and have 2x squared, sorry for the noise, 2x squared plus 14x, and then this total, which is 289 minus 49, because it's different signs, right? If there are different signs, you take the difference, and then you take the sign of the big dog, right? So this is essentially negative 240, and we've set it to 0. So this is a really nice setup for solving this stuff. It's not the answer, but we needed to get it started in this quadratic equation form. Okay, now we still have a little bit more to do in order to work with it, okay? First thing that I notice is that there is a 2 as a greatest common factor. That's another concept that you need to be fluent in. So what is the GCF here? Thankfully, this is just a really small number, right? But if we take the greatest common factor out, which is 2, okay, this would become 2 times x squared plus 7x minus, what's 240 divided by 2, everybody? 120, okay, equals 0, okay? Now I need to get rid of the 2, right? Because I need it back in my nice, fancy quadratic form. So I just divide both sides by 2. And guess what? This side stays 0, right? And this stuff cancels out here. Okay, just let that sink in for a moment. All right. Oh, man, it's not continuing on with the page like I thought it would. All right. I think I like the other app better, but moving right along. So this leaves me with x squared plus 7x minus 120 equals 0. Okay. We're about halfway through, ladies. So if you need to pause to rub your temples, close your eyes, stretch, go ahead and do that.